Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about Soliton 2027 batch short programming round that was conducted in my college, Banarama Institute of Technology. Okay, so they asked three questions. So those three questions are very easy, I think so. So see here, first one is sensor warning system. So in this sensor warning system, this particular question explains like let me first explain every question, then let us see about the solution for it. Okay, so here they will be giving you n sized array and minimum and maximum safe range values. Okay, and then an array of sensor values. Now they have given some conditions also. If all the values are within the range, then print safe, or else if more than half of the values are within the range, then print warning, or else you can print critical, and also you want to print the index of the out of range values also. Okay, so it is basically like a basic traversal technique, that's it. Okay, and we want to do this in a C programming. Okay, so the next thing is ATM withdrawal system. So telling about the first one is of basic model. Meanwhile, the second one is belongs to the greedy algorithm. Okay, so see here, ATM withdrawal system. So you have a notes of 2500 and then 200, then 100 rupee notes. Okay, where 2500 and 200. So these three notes are limited. So these three notes are given to you by the user. Okay, meanwhile 100 rupee note is unlimited. Okay, now hats off, now let us assume that the given number will be of multiple of 100. Okay, in future while solving this problem, I'll be showing you if it is not given like this, then what should we do. I'll be showing that. Okay, now listen this. So if the input is 1, 5 and 3, which means 2000 rupee note and 500 notes and 200 notes are given, right? Now they have given that the value we want to find is 3800. Then I can tell you I'll be taking 2000 note. Okay, then I'll be taking 3 500 notes and 200 notes and 100 rupee note. So they'll be asking you to find the minimum number of notes required. Minimum number of notes required to form the given sum. Okay, so this was the question. And the third question is, this is also one kind of the greedy question. Okay, so this question is already discussed in my YouTube channel. Okay, so this question is repeated from the Kongu college also. So see here, largest number smaller than the n. So this particular question is repeated question which was asked for the 2027 batch in Kongu college, that was repeated in the Banarama Institute of Technology also. Fine. So let me discuss about these two questions alone. If you want this particular third question, go to my description. I have the solution for this particular problem. Okay. So see here, let us first finish the first question. So first question is very easy. So let me take this particular thing here. Just a minute. Okay, now listen this. In the first question, they ask us to just input the array size. So get the input of the array size, then get the array. So here the array is 40, 10, just a minute, 35, 40, 10, 15, 45, 25. Okay, and what are the ranges? So ranges are 10 and 30. So it is so simple, right? So I'll be taking what are all inside the range. So what are all inside the range? Going to be initially 0. So I'll be basically traversing it. So 35. Whether the 35 is between this range? No. Whether this 40 is in between this range? No. Whether this 10 is in between this range? Yes. Yes, because 10 is equal to this 10, right? Which means it is also lying inside the range, right? So I'll be making the inside as 1. Okay, now 15, yes. So increase it by 2. Okay, now 45, no. 25, yes. So inside numbers are totally of 3. Okay, So what they have asked, if it is more than the half of the value, which means it should be strictly greater than. Just check with the question, okay? If in the question they have given that if more than or equal to the half of the values or within the range, like that, then we will be using the statement called warning, because what is the length of this array? It is 6. 6 divided by 2 is equal to 3. So we want which is strictly greater than 3. So we want some value which is strictly greater than 3, right? So but here we got 3. So 3 is not strictly greater than 3. So I cannot use this warning also. So what should I print? I should be printing the critical. Okay. So whenever we are traversing itself, we will be checking whether it is out of range or not. For example, here while I am traversing, this 35 is out of the range, right? So there itself I will be printing this 35, and this 40 is out of range. So there itself I will be printing the 40. Then this 45 is also out of range. So there itself I will be printing the 45. That's it. So tell me what is the time complexity. So it is going to be O of n, and space complexity going to be O of 1. So this is going to be a time complexity and space complexity analysis. Okay. So let me show you the code first. Then let us just go to the next question. So see here. Okay. So what is the first thing? I want to get the number of elements from the user. Then I'll be getting the maximum and minimum range, and I'll be declaring an array of size n, and then inside going to be 0 initially, and I'll be getting the array values. So this print statement is basically like what are the ranges that are, what are the indices that are out of range, like that. If you want, you can print the index. If you want, you can print the element also. That's your wish, okay, based on the problem statement. Okay, now I'll be traversing over the entire array, and I am checking whether it is in between the range. If it is so, I'll be incrementing in my inside. Else I'll be printing the index. At last, what should I do? I'll be checking whether the inside is equal to n. If it is so, it is safe. If it is greater than the half of the thing, so I can return the as a value as warning. If it is not, then I want to return critical. That's it. So this is going to be your entire code. Fine. So this is pretty much easiest problem. So let us go to the second problem. So let me take the question again. So let us get into the second problem. Okay. Now, what is the second problem? So in second problem, we are going to use greedy approach. So many will be having a dilemma on which approach I should be using, whether the greedy approach or whether I want to use the DP approach. Okay, many will be having the doubt like this. Okay, so in greedy approach, we will be taking the optimal solution. In DP approach, we will be going for all possible combinations, and I will be taking the optimal one. Okay, but greedy takes a little time, but DP takes a huge time. That's the main difference between them. And time complexity is also, in greedy it will be efficient more. Okay, but not all, I want to make this clear. All the greedy problems can be solved by using DP, but not all the DP problems can be solved with use of the greedy. Always remember this. This is very important thing. Okay, so here this particular problem follows the uniformity concept. What it means? See here, whatsoever value which I have given to you, which are divisible by 100, then you can tell me that I can form a denomination like this by using these values, right? For example, say 3200. So it is a divisible of 100, right? So in your worst condition, you will be taking 3200 rupee note. Can you understand this? 3200 rupee note. If it is of 1000, in your worst condition, you will be taking 1000 rupee note. Okay, so here this follows the uniformity concept. So whenever it is following the uniformity concept, I am going to use the greedy approach. So here the approach is so simple. If the given value is 3800, then I want to check from the topmost value to the smallest value. Okay, so what is the topmost value? So here the topmost value is 2000, right? 2000. So let us take this into a bit more complex thing. Instead of this, let me take like 6300. Let us take like that. Okay, 6300. where I have one 2 rupees 2000 rupees note and 5 sorry yes 500 rupee note, okay, and 3 200 rupee note and unlimited 100 rupee note they have given in the question itself. Okay, so let me take like this, okay. Now how many 2000s can be achieved for this particular thing? So always think like that, okay. So basically forgot about these all, if you have unlimited supply of 2000 rupees, then how many 2000 rupees note you will be taking? You will be taking obviously 3 2000 rupee note. Can you understand this? So 3 2000 rupees note can form 6000. Meanwhile, for 500 rupee, how many notes that is used to form this equivalent amount? Just check. So it is going to be 12, right? 12. So 12 5000 rupees note, 12 500 rupee note will form the 6000. So here which is optimal? Here taking the larger value as much as possible is going to be very optimal version. So this is going to be a greedy approach. Can you understand this? So here I am checking how many 2000 rupees are there. Only one 2000 rupees. But we can take at most of 3 2000 rupees note. But unfortunately we have only one 2000 rupees note. So I'll be just taking that one note alone. So how many note count are there? So only one note count. Hats off now. I took only one note. Okay. Now 0 0 3 4. Can you understand this? Okay. Now I have 500 rupee note. 500 rupee note. So in this 4300, how many 500s can I take? So I can put basically like 4300 divided by 500. So both things will be cancelled out, and here it will be 8 point something. So I can take around 8 at most. I can take at most of 8 500 rupee note, but unfortunately I have only 500 rupee note. So take the belonging alone. So it will be 2500. Can you understand this? Yes, I can take up to 8, but I only have 5. That's the reason I am taking like this. Okay, so 0 0. So borrow here 1 8. Sorry, here 3. So here 1. Okay. Now for 200 rupee note, how many notes I can take? I can take around 9 200 rupee note, but I have only 3 200 rupee note. So just take 3 alone. So 600. So just update the count. So here plus 5. I took 5 500 rupee note, plus I have took 3 200 rupee note. Okay. Now 9. So 0 0 2 1. Okay, fine. Finally we came to this particular thing. So we have unlimited supply of 100 rupee note, right? So 1200 rupee note will be equivalent to this particular thing. So I'll be adding plus 12. So which is equal to how many notes we want? We want totally of so here it will be of 9. So here it will be of 21. So output is going to be 21. So this is going to be your minimum number of notes you required. Okay. Now using the same thing in this particular example, let us see what will be the answer. Okay. Now 2000 rupee note will be 1, and then 500 rupee note will be 5, and 200 rupee note will be 3. Okay. Now let us run the algorithm itself, the greedy algorithm itself. Okay. Observe this clearly. This is going to be very important. Okay. Now see here, first of all I will be taking this 3800, okay, and I will be dividing this by 2000. It will be 1, and here comes 2000, and that's it, right? Here comes some remainder like 1800. So this is going to be a remainder, right? Now I can tell you I will be taking only I can take at most of only 1 2000 rupee note. I can take at most of only 1 2000 rupee note. So how many supply I have? I have only one supply. So take it. Don't do anything. Just take it. Okay. Subtract it. So after subtracting it, it is going to be 1800. Okay, now again take this 1800 divide by 500, divide by 500. So how many times it will be coming? It will be coming around 3 times, right? It will be coming around 3 times. So 1500, so remaining will be 300. So I can take at most of 3 500 rupee note, but I have 5 500 rupee note. So from 5 I can take 3. That's possible, right? So take it. So initially I took 1 2000 rupee note plus how many like see here 1000 rupee note, and how many 500 rupee note? 3 500 rupee note. Okay. Now do a subtraction to it. It will be 300. Now again divide the 300 divided by 200. So only one note I can take. Remaining that I cannot take. So I have a supply of 3 notes. So take one alone. So 1 200 rupee note. 200 divided. So it will be, when I subtracting it, it will be 100. Okay, I have unlimited supply of hundreds. So 100 divided by 100, which is equal to 1. So I will be taking 100 rupee note. So what is my denomination? So it will be 1 2000 rupee note, 3 500 rupee note, and 1 200 rupee note, and 100 rupee note. So this is going to be your minimum number of notes I want to take from each and every values. Can you understand this? So here they may ask in different kinds of question. So what is the minimum number of notes? Okay, or else they may ask this thing also, this particular thing also, like they have asked in this particular question. So in this particular question they are asking us to find what is the minimum number of note for each and every values. But they can also ask like in an entire thing, minimum number of notes also. Okay, so this is how this problem should be solved. And in another way they may say like, hey, I'll be giving you some values. If you can satisfy, if you can take some amount, okay, and those amounts denomination will be equal to this particular value, then return the number of notes, else return -1. They may ask like that. For example, if it is 3820, if it is 3820, can I form a denomination from 2000, 500 and 100 and 200? Can I make any number of denomination? No, because I have 20 here. I have 20 here. So I cannot make it. So how I will be finding it out? I will be just dividing by the lowest value. So if I divide this by the lowest value, what is the thing? So my quotient will be 38 and my remainder will be 20. So from here I can tell you I have a remainder called 20. So I cannot form this particular value. Can you understand this? So this is one of the kind. In second kind, when to use the DP, when to use dynamic programming, when to use all possible combinations. So when to use that, you may have that doubt also, right? So when it is not following the uniformity concept. For example, listen this carefully. You have 2000, then you have 500, then you have 200. Now they are asking you to find the denomination of the some particular amount. Then how you are going to do? You will be putting a greedy algorithm, right? But this greedy algorithm will be failing for some particular cases, right? For example, if I take 800, so first of all I will be dividing the 800 by 500, right? So what will be the number of 500 notes I will be taking? 1 500 note I will be taking. What is the subtracted value? So 800 minus 500, which is equal to 300. So again I will be taking 200 for only one note. I will be taking 1 200 rupee note. So remaining will be of 100. So whether I have 100 here? No. So that's the reason why whenever it is not following the uniformity concept, you want to just step into the dynamic programming. But you can also take 200 plus 200 plus 200 plus 200, which is equal to 800. Can you understand this? So this is what called the taking all possible combinations. Taking all possible combinations. So here your recursion call will be take and not take. Important recursion call. Okay, so I don't know whether these and all will be asked in a short programming round, but still learning this also will be very helpful for any other interviews. Okay, so learn about uniformity concept such a way that you can able to think whether I want to use the greedy algorithm or I want to use the DP algorithm. Fine. So that's it for the second thing. Let me show you the code. So this is going to be your code. First of all, I am just getting number of 2000 rupee note, number of 500 rupee note and number of 200 rupee note from the user. Okay. Next, I will be getting the total amount. Now, what is the usage of 2000? I will be keeping a 0. Similarly for 500, 200 and 100 also. Okay. Now, I am just checking whether the amount is greater than or equal to 2000. If it is so, then I can tell you I want to divide it by 2000. Okay. Now, again, if my used 2000 is greater than the number of 2000, then the used 2000 which is equal to number of 2000. What it means? If the given 2000 rupee note count is 5, but I can take up to at most 8, but I cannot take at most 8, right? I cannot take that 8 because I only have 5 2000 rupee note. How can I take 8 of them? So minimum among them it is 5. That's the reason why I taking the 5 in my used 2000 also. Now amount minus equal to used 2000 into 2000. That's it. Okay. Here if you don't use this condition also, it will be working fine. Okay. Now what is the next question? Next step is similarly for the 500 also. Similarly for the 100 also. Similarly 200 also. For 100 alone, since it is unlimited supply, we don't want to check the particular condition. Okay, directly divide by 100 and take it everything. That's it. Can you understand this? Okay, and finally you will be printing the every notes. So here you may get a question like in various format. I will be repeating this again. Just listen this carefully. In one of the format they will be giving the question like this. In another format they will be asking you to find the minimum number of notes that are required. Okay, so that is going to be every note. So at that particular time you want to add everything, use of 2000 plus use of 500 plus use of 200 plus use of 100. Okay, in another question they don't give you the hint like a greedy approach. Okay, they don't give the that particular value 100. If they don't give that particular value 100, you cannot make that sum. Can you understand this? So at that particular time you want to go to the DP. Okay, in another case they will be giving you like if you cannot make the denomination, then just print -1. At that particular time what should you do? You will be taking the smallest value and do a mod operation with the amount. If the remainder is not equal to 0, then there itself just written -1. That's it. Can you understand this? So this is what the 3 questions in a short programming round for the Bannerman Institute of Technology asked by the Soliton. Fine. So if you have any doubts in this, just comment below, and if you really understood these problems and learned something, just like this video and subscribe to my channel, and don't skip any videos in the Soliton playlist because all videos will be more helpful and many questions are repeated this year. That's the reason. Thank you.